this space behind?
It's a practice rugby field.
Oh.
Yes. And
This century is special. It's the first when one species, a human species, has the power to determine the future of life on Earth. I think the chance of some serious global setback to civilization is indeed quite high.
When you started your research career as a cosmologist, the existence of the cosmic microwave background, the afterglow of the Big Bang, had only just been discovered.
Yes.
And the Big Bang theory itself was not set in stone.
Mm-hmm.
How much has cosmology changed?
Mm-hmm. I started research in Cambridge in the mid-60s, and at that time Fred Hoyle was a professor, and he was still advocating the idea of a steady-state universe which had existed from everlasting to everlasting, expanding all the time and new galaxies forming all the time. The contrary view was the Big Bang theory, and the evidence for the Big Bang theory was really very weak. And this was a genuine controversy, but it was, in most people's minds, settled in 1965 when the so-called cosmic background radiation was discovered. This is the discovery that the entire universe is full of microwaves which have the spectrum indicating that they're relics of a hot, dense early phase of the universe. But that was a big discovery. But it was a good time to be starting research, not just because cosmology was taking leaps forward, but also because for the first time, objects were being found where Einstein's relativity was important, not just a tiny correction which it is in the solar system. These were the objects that we now realize are black holes and pulsars, which are neutron stars, where gravity is very strong. And at the same time, there were important theoretical developments. And the leading figure here was Roger Penrose, who developed new techniques to solve Einstein's equations. And this was a big leap forward in relativity theory. And I was very lucky to be in a place where all this was going on.
When we talk about the Big Bang, of course that is our established view of how the universe started, regarded by many as set in stone. Should it be, given that we don't actually know what the Big Bang is?
As in all of science, every advance opens up new questions that couldn't have been even posed before. I would say that we can understand the physics of the universe right back to when it was a microsecond old. And that's an amazing achievement. Because we've understood this, then we've realized that there are new key questions about the universe which we can at least pose. The question is, why is the universe expanding the way it is? Why does it contain the mixture of atoms, radiation and dark matter which we observe? And why did it have, right from the beginning, the kind of irregularities which result in it not remaining as uniform gas all the way through, but developing galaxies and clusters of galaxies? And the answer to all those questions lies before the first microsecond was up, to the stage when the observable universe was the size of a tennis ball. And that's more speculative because we've got no experimental foothold in the very, very extreme physics.
And yet, the spectres of dark matter and dark energy, the fact that 95%, more than 95% of the stuff in the universe comes in forms we can't detect or we can't explain.
Well, clearly our knowledge is incomplete. We know some properties of dark matter. We know it behaves like neutral particles in a swarm that don't collide with each other, and that fits the data very well. We know there's about 5 times as much mass in that form as there is in atoms, and that allows us to get a very good model of how galaxies form. As to what the dark matter is, we don't know. It's easy to envisage particles we haven't discovered yet, and very, very hard to discover. Because there's no reason why everything in the universe should shine. The so-called dark energy is telling us something we don't understand about space itself. It's saying that the vacuum is something which has properties. exerts a force which causes the universe to accelerate. You'd expect the universe to be decelerating because every galaxy exerts a gravitational pull on everything else, so though expanding, it should be decelerating. This is one of the big challenges. It's really related to what I said earlier, talking about the very, very early universe. The dark matter, I think there's a reasonable hope in the next 10 or 20 years of making progress into what it is, whereas the dark energy, I see far less hope of that. It'll be a much longer process.
And as you said, you've taken a great personal interest in the multiverse. And one thing that you've been very interested in is anthropic reasoning. So that this idea that certain characteristics of the universe are as they are because we are there to observe them. Can you explain what the connection there is?
Well, one of the theories we have that would explain what happened under these extreme conditions is string theory. And according to that theory, the vacuum, empty space, is not simple. It's got microstructure in it, and there may be many different versions of the vacuum. And if Linday was right and there were many big bangs, then they might cool down in such a way that they ended up with vacua or space with different conditions. If the space was different, then the laws of microphysics would be different. Strength of gravity, strength of the nuclear forces, mass of the electron, all those things. And this would lead to the possibility that there were many, many big bangs, and only some subset of them had the properties which allowed complexity and life to emerge. To take one example, if gravity was very strong, so that objects as big as us couldn't exist without being crossed by gravity, then clearly that would be not conducive to the evolution of life, and so we need gravity to be important but very weak. It's saying that reality is very complicated. It's just like the many things we can't predict. We can never predict the weather a month ahead because of chaos theory, and it would be saying that the things which are normally treated as fundamental numbers, for which you might expect to eventually find some exact formula, like the mass of the electron, the strength of gravity, etc., may in fact be, in this much grander perspective, just local parochial bylaws, as it were, applying in some part of the universe. So it would be just saying that the universe is much more complicated. It wouldn't say that we failed. It's just as you can't blame weather forecasters for not giving an exact weather forecast.
Of course, we've just seen the James Webb Space Telescope launch and recently reached its destination. What do you hope that the James Webb Telescope is going to achieve?
I think there are two very important but very different fields that it's going to illuminate greatly. One is it's going to tell us about the very early stages of galaxy formation. We talked already about the Big Bang, but what happens is that when the universe is about 500,000 years old, its temperature drops below 3,000 degrees, and the primordial radiation shifts into the infrared. Universe enters a literal dark age until the first stars form and light it up again. And we'd like to know when that happens. Do the first stars form already in galactic structures or separately? It will certainly tell us a great deal about what happens when the universe was about 100 million years old, 1% of its present age or thereabouts, when the first stars and structures were forming. But there's something else which I think is equally important and probably of even greater interest to the wide public, and that's it might find evidence for life in the universe. This is because one of the most exciting developments in astronomy in the last decade or two has been the realization that our solar system isn't all that special. If there was an Earth-like planet around one of the nearest stars, then the Webb telescope might be able to image it and take a crude spectrum of its light. The exciting thing would be if it showed any evidence for life and vegetation. If we're lucky, then the James Webb Telescope is the first which will stand a chance of finding evidence for life. But as I say, this is probably just about at the limit of what James Webb can do. And I think if I can look ahead 50 years, when I won't be here, I would hope that 50 years from now, there will be large telescopes assembled in space, much, much larger, which will be able to not merely detect the light from one of these extrasolar planets, but see it as a resolved object, not just a point source, and get a crude picture of it by 2068. Why do I say 2068? That will be 100 years after the famous Earthrise picture. And it would be great if 100 years after that we could detect an image of another Earth.
You have in your career been greatly interested in the search for extraterrestrial intelligence.
Yes. Mm-hmm. So my personal view is that if SETI searches get any positive results, seeing some obvious artificial artifact or detecting some transmission, it's unlikely to be a flesh and blood civilization like ours. It's far more likely to be some exotic and possibly malfunctioning electronic entity. And another reason I say that is that if you think of the time spans, our technological civilization is, depending on where you start counting, no more than a few thousand years old, and it could be less than another 1,000 before it's usurped by electronic entities. And that few thousand years is a very thin sliver, not only compared to the 3.5 billion years of Darwinian evolution, but also compared to the billions of years that lie ahead. And so that therefore means that if there were another planet in the galaxy which had evolved like ours, then it would be most unlikely that it was synchronized so that we would catch it in this sliver where it was flesh and blood civilization.
I wonder about the concentration on electronic organisms. Could we even... There are other forces of nature. And
Yep. I completely agree that, of course, since we are not the culmination of intelligence and understanding, we've got to be mindful that there could be aspects of reality which are of deep importance, of which we are completely unaware, which our brains couldn't grasp. And so it could be that there is complexity and intelligence out there of a kind which is so different from anything we can envisage or what our minds can grasp. And so I just think we should be entirely open-minded.
Doesn't that open the door to so many people who think they've seen these things already? I mean, how do you distinguish what's credible as an unexplained phenomenon from something that is merely something explicable?
Yes. Well, the answer is with difficulty and with some assessment. Of course, I get a lot of letters from people who think they've seen aliens, been abducted by them, etc. And of course, lots of people do claim this. I think my line is to say that do they really think that if the aliens had made a huge effort to come here, they'd just have met one or two well-known cranks, maybe made a corn circle and gone away again? It doesn't seem very likely, and that's why I tell these people to write to each other and not to me. That's a slightly cynical response, but I think it's possible to be open-minded about the possibility of these things, and yet sceptical of any individual claim.
You mentioned just now in talking about the likelihood of encountering alien intelligence, about the lifetime of technological civilizations such as our own. And you estimated the probability of our extinction by 2100 as about 50%. Is that 2 decades on? Do you stand by that? Has it become more or less likely?
The way I present this is that the chance of something wiping out every human is small. But on the other hand, I think the chance of some serious global setback to civilization is indeed quite high. And this century is special. It's the first when one species, the human species, has the power to determine the future of life on Earth. Of course, one started saying things like that when nuclear weapons were developed, but we now have bio and cyber and genetic modification and all those things. We know that it's possible through so-called gain-of-function experiments to make a virus more virulent or more transmissible. This could be done using equipment available in many industrial university labs by just a few people, and that could create a global catastrophe. And similarly, cyber attacks, we know they can be done genuinely by people in their bedroom, as it were.
How do you think we should respond? What should we be doing that we shouldn't be doing?
COVID-19 has been a wake-up call. We are dependent on networks. I mean, supposing the internet had failed during the lockdown, wouldn't that have made it far worse? And we've learned that we need to be more resilient. We shouldn't depend on supply chains when a single link disrupts manufacturing and all that. And also, to take another example, we should keep a lot more slack in our hospitals. It's efficient to have 95% of your beds occupied all the time, but that's not resilience. It's possible for a small group of people to create something which is a global catastrophe. And that is, I think, a real risk. And I think to cope with that, we're going to have to contend with a tension between three things we want to preserve. One is freedom, the other is privacy, and the other is security. And of course, without intrusive surveillance, it's very hard to be confident of this.
You mentioned in passing climate change, yes, and related to that, biodiversity loss.
The problem is, of course, that when something sudden like COVID-19 happens, then politicians and the public are immediately aware that they need to do something about it, whereas these are slow burners, as it were, and we're rather like the frog in the pot of water is being heated, not taking any action until it's too late to escape. In the case of climate, we've got a long way to go, but one step which is encouraging is the emergence of charismatic figures who are helping to alert public opinion. And I would mention four very different, disparate figures who collectively had a big impact. Pope Francis, our secular Pope David Attenborough, Bill Gates, and Greta Thunberg. All different from each other, but together they have had a big effect on public opinion in many countries. And we've got to remember that the UK is the emitter of only 1 or 2% of the world's CO2 emissions. So even if we meet our zero targets by 2050, that's in itself only a small contribution. What's more important is the 4 billion people who will be in India or sub-Saharan Africa by 2050. They are going to need more per capita energy if they're to develop. And if we can somehow enable them to bend over the curve and leapfrog directly to clean energy, just as they've leapfrogged directly to smartphones and never had landlines, then that will be something which does more for the world than simply meeting our own target.
When you were starting out your scientific career 50 years ago, it was the era of the original space race. And yes, now we've got the billionaires space race.
Yes.
Private companies, Elon Musk, Jeff Bezos, What do you make of that and their motivations?
Well, it's very interesting because, as you say, the Apollo program is a long time ago. I mean, I remember it, but it's long before all today's students were born. To them, it's ancient history. They know that the Egyptians built pyramids. They know that the Americans went to the moon, but these both seem ancient achievements with rather strange motivations, as it were. And of course, I remember watching the Apollo landings, and I thought then that it might be only 10 years before there were footprints on Mars, given that it was only 12 years between the first Sputnik, the first thing in orbit, and the first moon landing. And of course, had the funding level remained at the huge 4% of national budget level, which it was in America during the Apollo program, then that was possible. But of course, it was done as a stunt and superpower rivalry, and so the budget of the superpowers for space was cut back. And so that still remains the high point of human spaceflight. Space has burgeoned in a number of ways. I mean, obviously, as a scientist, I benefited hugely from telescopes in space, and miniaturization has been advancing fast, and now robotics is advancing fast. The practical case for astronauts is getting weaker all the time, but I would be interested in Messrs. Musk and Bezos, and I would cheer them on, actually. And the reason I would is that they can do this more cheaply because they can afford to take higher risks than NASA or any Western government could impose on publicly funded civilians. If you look back to the space shuttle, it was launched 135 times. It failed twice, 2 catastrophic crashes, and each of those was a big trauma in America. A less than 2% failure rate is acceptable to test pilots, acceptable to the kind of thrill seekers who go hang gliding and that sort of thing. And so I think that if Messrs. Bezos and Musk want to have a program of manned spaceflight for thrill seekers prepared to take a risk, then that is great. And of course, Elon Musk has said that he wants to die on Mars, but not on impact. And he's now 50 years old, but 40 years from now, he might do that, and good luck to him. And incidentally, one reason why I would wish them good luck is that there will, by the end of a century, obviously be far more scope for human enhancement, etc., by genetics and also by cyborg techniques. If there are these crazy guys on Mars, then of course they're in a very hostile environment, and they will have every incentive to adapt themselves to that environment, and they'll be away from the regulators. So if there is to be a sort of post-human species, then it'll be progeny of those guys rather than happening here on Earth. But even if by the end of a century there is a small colony of these adventurers on Mars, I think it's a dangerous delusion to imply, as Musk does, and as my late colleague Stephen Hawking did, that there can be mass migration to Mars to avoid Earth problems. Dealing with climate change on Earth is complete doddle compared to terraforming Mars to make it habitable. And so we've got to deal with the Earth's problems on Earth.
When we look 50 years into the future, where do you see us being? Are you a pessimist or an optimist?
Yeah. Well, I think it's clear that lots of technologies now are hugely beneficial. But what makes me depressed is if we look at the world today, the gap between the way it is and the way it could be is wide and probably widening. And so that makes me not very optimistic about the extent to which we will employ these new technologies optimally.
Looking back 50 years over more than 50 years of your scientific career, what achievements in any field are you most proud of?
Well, I think I wouldn't claim any great individual achievements, but I think I've been very lucky to have participated in exciting debates which have led to growth in the understanding of the cosmos, galaxies and stars and everything. And I think when the history of science in this half century is written, then I think the expansion of our understanding of the cosmos will be one of the exciting chapters. And I'm glad to have been a sort of a ringside spectator.
Martin, thank you so much. It's been a marathon, but well worth it.
Okay.
Thank you so much.
Yeah.